Okay, this is chapter 6, and we're in 6.4, exponents and square roots. We're going to be working with exponents using the order of operations and finding square roots. When the same number appears many times in a multiplication, writing the product may become monotonous, tiring, and even inaccurate. It's easy, for example, to miscount the 2's in 32,768. When you're typing it in the calculator, if you have to do 2 times 2 times 2 times 2 this many times, right, to get your answer. Or in tens, if you want to write 100 billion, 10 times 10 times 10 times 10, and so on. Products of this sort are usually written in shorthand form as 2 to the 15th power and 10 to the 11th. In this exponential form, the raised integer 15 shows the number of times that 2 is to be used as a factor in multiplication. So, for example, 2 times 2, since we have 1, 2 of these, would be 2 to the 2nd power. In this one, we've got 1, 2, 3 2's, so 2 to the 3rd power. 1, 2, 3, 4 2's, so that would be 2 to the 4th power. In this last expression, 2 is called the base, and the integer 4 is called the exponent. The exponent 4 tells you how many times the 2 must be used as a factor in multiplication. So if we had 4 to the 5th power, the 4 would be the base, the 5 would be the exponent, and this would simply mean 4 times itself listed 5 times. Find the value of 4 to the 3rd power. Well, we would want to say 4 would be our base, so we would list the 4 times itself. 3 times is what direction our exponent gives us. And when we do 4 times 4 times 4, if we're following the order of operations, we would multiply 4 times 4 and get 16. Then we'd multiply it again and get to the 64th power. Most people's calculators will handle this. There's a button on your calculator that looks like, we call it rooftop, but or some people call it a caret. But if you type in 4 rooftop 3, it will give you the answer of 64. It is important that you be able to read exponential form correctly. 2 squared is read 2 to the 2nd power or 2 squared. This is read 2 to the 3rd power or 2 cubed. This is read 2 to the 4th power, 2 to the 5th power, and so on. Students studying basic electronics or those going on to another mathematics or science class will find that it is important to understand exponential notation. Notice that negative 3 to the 4th is equal to positive 81, but negative 6 to the 3rd is equal to negative 216. The rules for multiplying signed numbers tell us that a negative number raised to an even power is going to be positive, but a negative number raised to an odd power is going to be negative. And why is that? If I do negative 3 to the 4th power, that means negative 3 times negative 3 times negative 3 times negative 3. Well, these two, we would be doing a negative times a negative, which is a positive, another negative times a negative, which is a positive, which would make our answer be positive. When I'm doing negative 6 to the 3rd equals negative 216. Well, a negative 6 times negative 6 times negative 6, these two right here would be a positive, but then we're multiplying that by a negative, and remember when the signs are different, we get a negative answer. Be careful when there's a negative sign in front of the exponential expression. For example, 3 squared is 3 times 3, which is 9. Negative 3 squared means negative 3 times negative 3, which is also 9. But if you have negative 3 squared, this simply means this. And notice that the negative would be on the outside. It's different than this, right? The negative would be on the outside of the parentheses. And so negative, you would do the 3 times 3 first, which would be 9, and that would just simply be negative 9. The negative inside the parentheses means you're saying negative 3 times negative 3. The negative on the outside of the parentheses means you're saying 3 squared and then multiply it by your negative. To calculate negative 2 to the third, we must first calculate negative 2 to the third, because the order of operations say to do exponents first. So we're not worried about this negative in the front until the end. Okay, so they've got it right here. They took negative 2 to the third, negative 2 times negative 2 times negative 2, and got negative 8, which is what we have right here. And then they've got negative times negative, which is a positive 8. A useful way of remembering this, exponents act only on what they touch. So if it's inside the parentheses, that's what you're going to consider. Special bases and powers. Here are some useful facts about special bases and powers. The number 1 raised to any power is equal to 1. So 1 squared, 1. 1 to the third equal to 1. 1 to the fourth is equal to 1. 10 squared, notice that when the base is 10, the product is easy to find. 10 squared is 10 times 10. There's 2 zeros here. 10 to the third, 3 zeros. 10 to the fourth, 4 zeros after the 1. 10 to the fifth, 5 zeros. A whole number exponent is always exactly equal to the number of zeros in the final product when the base is 10. So continue the pattern to find the value of 10 to the 0 and 10 to the first power. So if we say 10 to the fifth is 100,000, to get the next one we would divide by 10, which would give us 10,000. To get to the next one, divide by 10, which would give us 1,000. To get the next one, we would divide by 10, which gives us 100, divided by 10, which gives us 10, and then divide by 10 divided by 10 is 1. Okay, and so this is a very interesting one. 10 to the 0 power is 1. Same thing, anything raised to the first power is always going to be itself. Anything raised to the 0 power is always going to be 1. This is one of those that tricks a lot of people. If I say 1 million, okay, and I raise it to the 0 power, it's 1. Negative 3 to the 0 power, 1. Negative 1 to the 0 power is 1. Anything raised to the 0 power is going to be 1. Order of operations with exponents. First, simplify all operations with parentheses. Second, you're going to simplify your exponents. Third, perform all multiplications and divisions from left to right, and then additions and subtractions from left to right, which we've talked about this before in class. Please excuse my dear Aunt Sally acronym for remembering that. So to calculate 12 plus 54 divided by 3 squared, you would look for parentheses. We don't have any. So the next thing you would do is look for exponents, and I see one right here. That's why they've gone and went ahead and dealt with the 9. Okay, multiplication and division would come next, so they took care of the 54 divided by 9 to get 6, and then finally they took care of their addition to get 18. In this problem, we do have some parentheses to take care of, so 2 times 3 got them 6. After parentheses is exponents, so they took care of 6 to the third next, which was 216. And then finally, they took care of the subtraction. To square a number using a calculator, enter the number, then press the x squared key, followed by the equals key. So if you want to type in 2 squared, you would type in 2, and then you would hit the x squared button, and then you would hit 2, well, no, actually you would not have to. If you hit the x squared button, you just hit that. What should show up on your screen when you do that is 2 squared. Okay, but you could also type in this. You could type in 2 and then hit the rooftop button squared, which would get you the same thing. So the value of 38 squared can be found if you type in 38 x squared, or you could type in 38 rooftop 2, 1,444. The value of 3.8 to the 5th power, and they're using the rooftop button here, 3.8 rooftop 5. You really have to use the rooftop if you're doing anything other than squared. So that's why you could just use it every single time if you wanted to. But if you use the rooftop button, that will get you something to the 5th power. To calculate negative 25.4 squared, you want to type it in exactly like it is. So you want to make sure that you hit those parentheses. If it's written in parentheses, you hit the negative button, not the minus button. The negative button is usually down by 0. 25.4, close your parentheses, hit the x squared button. You should be getting this. Now, practice in your calculator with the rooftop button and make sure you're able to get that. Okay, great. The percent resolution of an 8-bit digital to analog converter is given by the calculation 1 over 2 to the 8 minus 1 times 10 squared. So if we wanted to type this in the calculator, if you've got the TI-84, I would use the fraction key to do that. If you don't, you want to do your order of operations. So they didn't have any parentheses, but they simplified their 2 to the 8. Then they got 256 minus 1 on the bottom. And they went ahead and simplified that, because remember, whenever you have a fraction, you want to treat it like it's parentheses and figure out what the top and the bottom are. Now we could just type in 1 over 255 times 100, and we would get this 0.3921. Okay, so they've got an example of how to type it in the calculator down here. A lot of times people will do 1 divided by, and then if they want that whole thing to be on the bottom, they would do 2 rooftop 8 minus 1. Okay, and then they would type their times 10 squared. So, and that would get them the correct answer if they did that. Perfect squares: 1, 4, 9, 16, 25, 36, 49. These are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. The next one would be 7 squared, right? Those are perfect squares. So here's a list of your perfect squares up to 20. And what is square about 3 squared? It's a good question. The name comes from an old Greek idea about the nature of numbers. Ancient Greek mathematicians called certain numbers square numbers, or perfect squares, because they could be represented by a square of array dots. So 4 would be 4 dots, which is 2 squared. 9, we've got 3 rows of 3, which would be 3 squared. 16, we've got 4 rows of 4, which would be 4 squared. When you square the number or multiply it by itself, you can obtain the original number. The symbol square root is used to indicate the square root of any number written inside the symbol. Okay, So what about the square root? The square root of 16 is 4 because 4 times 4 is equal to 16. So if I say, well, what is the square root of 16? I could go, well, 16 is a perfect square. 16 is 4 times 4, and I've got a pair of 4s here, so that would give me 4 as my answer. The square root of 64 is equal to 8 times the square root of 8 times 8, so my answer is going to be 8. The square root of 169 is going to be 13 times 13, which is going to get me 13. Every positive number actually has two square roots, one positive and one negative, which is something you probably didn't learn whenever you were first introduced to square roots whenever you were in school. So, for example, both positive 9 and negative 9 are considered to be the square roots of 81 because positive 9 squared is equal to 81 and negative 9 squared is equal to 81. Let me show you what I'm talking about. So if I take the square root of 81, I could write it like I just wrote it a while ago, and I could say 9 times 9, so I know that the answer is 9. But if I take the square root of negative 81, there's something else that's true about, I'm sorry, I meant to write that again as 81, sorry. There's something else that's true about the number 81. I could also say that negative 9 times negative 9 is 81 because a negative times a negative is a positive. So negative 9 times negative 9 is also 81. So the square root of 81 could be 9 or it could be negative 9. Now notice that they put the negative on the outside of the square root this time. So if we wanted to ask for negative square roots of 81, we would write negative 81 so that would be, the answer would be negative 9. If we wanted to ask for both square roots of 81, like I've done above, 9 and negative 9, they would put a plus or minus on the outside so that you would know to put both of the answers. In trade works, we rarely, if ever, use the negative square root of a number. How do you find the square root of any number? Using a calculator is the easiest way to find the square root or other power of a number to find a square root. To find the square root of a number, simply press the square root key. On most calculators, the square root key will be, you'll hit the second button, and then you'll find the x squared button. And right above the x squared button, you'll probably see a little square root. That will give you the square root, and then you'll type in whatever you're wanting to find the square root of. To calculate the square root of 237, you're going to type in second x squared most of the time to get your square root to come up, and then your 237, and you would get a very long decimal because it doesn't have a perfect square. Some calculators automatically open parentheses with the square root, so when you type it in, it's going to bring up a parentheses already, and our key sequences will be based on ones that do. If you have the TI-84, that's what it's going to do. However, unless there are additional calculations after the square root is taken, it's not necessary to close those parentheses before pressing equals. So in other words, if you're just trying to calculate the square root of 9, the calculator, when you hit square root, it'll automatically bring up a parentheses. If you don't have anything else, though, you could just type in equals. If you have the square root of 9 plus 7, and the only thing under the square root is the 9, you're going to want to type in square root of 9, close off your parentheses, then plus 7. Because if you don't, it'll keep taking the square root until you close the parentheses. Okay, so if there's nothing after the square root, you don't have to close the parentheses, but if there is, you need to. Notice that you cannot take the square root of a negative number. There is no number such that the square root times the square root of negative 81. So basically, these numbers do exist. They're imaginary. We're not going to go into that in this class, but what it's trying to say is, can you think of something times something else that is negative 81? So Well, no, because the number has to be, these two numbers have to be the same. So I would have to say like a positive 9 and a negative 9, those are numbers are not the same, so we cannot think of anything that's going to give us negative 81 underneath the square root. So those are imaginary numbers. Our calculators don't really function with those. Square roots have the same place in the order of operations as exponents, so that's important. Square roots and exponents have the same place in order of operations. So first you're going to simplify the parentheses. Second, you're going to deal with exponents and square roots. Because basically a square root is an exponent. We can talk about how to write it that way, but they mean the same thing. So for example, if you have 3 times the square root of 49, this little 3 out here in the front means that we're going to say 3 times the square root of 49. We're going to take the square root of 49 first, which is 7, then we're going to multiply. 2 plus the square root of 64, you're going to take the square root of 64 first, which is 8, then you're going to add. The square root of 81, take that square root first, then you're going to divide. If an arithmetic operation appears under the square root symbol, perform this operation before taking the square root. For example, the square root of 9 plus 16 is the square root of 25. So they added the 9 and the 16 first, and then, because it's kind of like these are parentheses under here, you're taking care of that first, then you're going to take the square root. Notice that the square root of 9 plus 16 is not the same as the square root of 9 plus the square root of 16. Do not do this. This is a no. Add them first, then take the square root. This is not true. To calculate 38 squared times the square root of 3, enter the following sequence. So they've got 38, x squared would get you the squared on the top, times the square root of 3. They did close off their parentheses. I think they forgot to open one up. When you type this in, this automatically comes up. Square root, and then they've closed off their parentheses, divided by 4. Okay, or you could type in 38 and then do your rooftop 2 times the square root of 3. You could figure out what the top is, and then you know that 4 goes on the bottom. So we would do whatever the top is divided by the bottom to get our final answer of 625.27033415. I really like it. I think you make less mistakes if you stop trying to type in everything at once. If you do have a TI-84, you can make it. If you can make it look just like this, which you can on the TI-84, you want to do that because that is going to always be exactly correct. So we've got to calculate the square root of 17 squared minus 15 squared. So you're going to get your square root button to come up, and then you're going to do your parentheses, 17, and then rooftop 2 minus 15, rooftop 2, then close your parentheses because you want to take the square root of all of that, which is 8. You could also use the x squared button instead of doing the rooftop 2. That would be fine here. So 2 different ways to do that. A grower wishes to plant flowers in a square plot containing 1,500 square feet. What should be the length of each side of the plot? So we know that we're looking for some number times some number that's going to give us 1,500 square feet. Okay, so we need the same number by itself. To get that, we would take the square root of 1,500, which is coming up to be about 38.7, and they've rounded to 38.7 feet. That's the end of chapter 6. If you are really confused about how to do these square roots in your calculator, you can look under the calculator help that I posted in chapter 6, and that will help you with the TI-84 calculator in typing these in.